G'day everyone, how are you going? I'm in a new class now. This is actually my Year 11 applications class, so I've got a new bunch of people here. Let's have a look at them. They want to be seen. Here we go. Very close up of me. Oh, there we go. There's my new guys. There's my new guys. Love and life. This is perfect here. So, let's get a bit of maths happening. What are we doing? We're in the ratios kind of area of the course now. So, what we're actually doing is working in a couple of different questions. There's three kind of prime questions that come through. I want you to see these and then you should be able to work any in this area. This question's our first one, our more simpler type question. We need to know what this is telling us. So, A:9, that's a ratio right there, and this is another ratio. And this question is saying that these two ratios are equal, so therefore we should be able to figure out what the A is. Now here's the tip. Break this down into a couple of fractions. See a ratio as a fraction, A over 9, and this is a fraction 2 over 3. Once you can see that that's a fraction, it's pretty easy to say, well, why don't I take this, multiply it up to here. 9 times 2, that's going to be 18. Divided by 3, that's going to give me 6. So A is going to be equal to 6. Now that kind of fits because look, the first number is smaller than the second. The first number is smaller than the second. Now they come in lots of different varieties here, but they essentially break down to the same. One that came up just before, which I need to show you. What happens if this ended up, I'm just using another question, as 6 over C equal to 9 over 12? Well, in that sort of question, you might go, the C's on the bottom, what's going on here? We as mathematicians take the whole thing and turn it upside down. So this becomes C over 6 equals 12 over 9. Now that is pretty much the same as that. Multiply away, tidy up, and you're done. So if you do end up here, flip the whole thing upside down, then rearrange and work. Right, let's get rid of that. We don't need that one. Okay, question number 2, or the second type of question, is this interest rate type question. What this has told me is to say that I invest some money for 3 years at 8% simple interest, and at the end of it, I've got $1,008. How much did I put in at the start? Well, first of all, we've got to recall our simple interest formula. Isn't that P times R times T over 100, where we put the rate in as a percentage? Now this is grand. It's the formula we need, but I don't know how much interest I earn. Remember, this formula works out just the interest, not the total. So I need to modify my formula a little bit. I'm going to do this. I'm going to say that the total is equal to the principal plus the interest. So now I've got a formula there to work with, and what I can see, or hopefully you can see, is that this guy is going to go in there, that guy is going to go in there, and that one is going to go in there, meaning the only thing that I don't know is the principal. Now if you've got a ClassPad calculator, this is in a calculator section, go solve 1008 equals x plus, set up a fraction, x times 8 times 3 over 100, enter, it'll spit out the number. And what is it spitting out? It's spitting out what the principal would be equal to, the initial amount that you put in. Now, because I know that over this 3 years I've earned some money, the number I get for the principal must be less than 1,008. At a guess, I'm going to say it's 950 or something in that order, okay? So if you got an answer here and it was $1,200, you know you're wrong because you had a final value of 1,008. How can you start with more than you end up with and earn money? So this sort of question is one of those ones where you kind of already roughly know what the answer is. Okay, third type of question. I squeezed it in over here. Let's go around a little bit. There we go. Perfect. So this sort of question, it said there was a tree in the woods and it cast a shadow of 24 metres. The sun was shining, shadow, you measured it out, 24 metres. You also put a stick in the ground. Stick in the ground, 1.8 metres. That's pretty much my height. And that shadow was 3.2 metres. So now what you've got to recognise here is you've actually got similar triangles. Because it's at the same time, the angle of the sun is exactly the same. All right? So the angle here and here is going to be the same. All right? Now this dashed line, we can't see that in real life. That's kind of the edge of the line of the sun. All right? If that angle is the same, and let's assume that the tree grows vertically, we kind of have to, and we put the stick in the ground vertically, well, if those two angles are the same in both triangles, then this angle here is also the same. And if that's the case, then these are similar triangles, and what I can do then is write a bit of a ratio. I'm going to call this one here h, height of the tree, that's what I want to find. So I'm going to write h over 24 equals to 1.8 over 3.2, because the ratio between those particular measurements has to be the same. Okay? I could then rearrange this by moving this guy up over here, make it a times 24, solve that, and I'll get the answer to the question. Now, think about this. Just like this one, I said the number's got to be less than 1008. Look at this. 1.8 metre stick got me a 3.2 metre shadow. The shadow was longer than the stick. So therefore the tree has to be less than the shadow, or the shadow longer than the tree. Okay? So I would expect an answer of 15 or 16 metres, something like that for the height of the tree, and that kind of seems realistic for a height of a tree in the woods. Hope this one's helped. I'm excited to be in Year 11 apps, getting some of these videos done. Hope you enjoy them. See you later.